Morning students. Today we will do some more question of the exercise 6.2 and we'll finalize the exercise. Look at question number doing here 14th one. Question 14 says find the least value of a for which function x square plus ax plus 1 is increasing in close interval 1 2. I made few changes here. As you can see in the book, here it is strictly increasing was written and it is open interval. But that time we cannot find the least value of a. So that I made a small change and I made this as in correct order, increasing and close interval 1 2. So this is the correct question. You can see that. So what question says? Question says that we have to find the least value of a for which function is increasing in 1 2. Meaning we are given that function is increasing. We are given that function is increasing. So we don't have to show. We are given already function is increasing. So how to go through the question I tell you? Very simple. First we'll find f dash x, which means 2x plus a. And we are given that function is increasing. And one must know that when function is increasing, f dash x is greater than or equal to 0. So what is a function? Differentiation of the function is 2x plus a, which is greater than or equal to 0. So what to do, student? We are given that function is increasing in interval 1 2. So one by one we will put the value of x is equal to 1 and we will find the value of a and high value of 2 for the interval x equal to 2 and then get value of a. So we don't want to put all the between values because we are putting only the least value and two highest value. We can call that we are putting the extreme value of the interval. Now if x is equal to 1, if we put here 2 ones are 2 plus a gonna be this and this after transferring to 2 I would have a greater than or equal to minus 2. And if x is equal to 2, if I'm putting here extreme value 2 2s are 4 plus a, so I would have a equal to minus 4. So can you simply judge here that is a greater than or equal to minus 2, it is a greater than or equal to minus 4. Can you go on a number line for y? This is minus 2, it is a minus 4, excuse me. It is a minus 4, it is a minus 2. It is saying a greater than or equal to minus 2. A equal to or greater than minus 2. It is equal to or greater than minus 4. So can you catch the picture and can you tell me the least value of a? So a having a lots of values but least value is not minus 2 but least value is a minus 4. So by picture we can say that least value of a is equal to minus 4. That was a simple question when function was increasing in the interval 1 2, so that after differentiation what we had the condition f dash x greater than or equal to 0 because it is already given the function is increasing. We put in the extreme values instead of x and we got two so possible values of a. So whatever the possible values of a, this and this. So finally after making the simple picture we can conclude that minus 4 is the least value of a. So this was a simple question but important, so that I told you. Now I'll move on to next question. We have 15th one. Let I be the interval disjoint from minus 1 to 1. Prove that x plus 1 by x is strictly increasing on I. This question, when you read the question, question will feel bit tough, but we first have to understand that what to go on. I, what is I? I be the interval disjoint from minus 1 to 1. It means that we have a set I which is disjoint with minus 1 and 1, meaning I and this have no common element. Disjoint meaning when A and B are disjoint, their intersection is phi. In class 11th we read A and B are called disjoint when A intersection B is equal to phi, when I with the interval which is disjoint with minus 1 to 1. So it is very clear that your I is the set which is except minus 1 to 1, meaning minus infinite to open interval minus 1. Look at and 1 to infinity, we exclude minus 1 to 1 because it is disjoint set. So what is our I? I will be minus infinite to minus 1 and 1 to infinite. So as per question, students, as per question, since I is the interval disjoint from minus 1 to 1, so that I will be minus infinite to minus 1 union 1 to infinite. So this is our I. Now what to show? Prove that function is strictly increasing on I. So what to prove? Strictly increasing. So what to prove? F dash x always greater than 0. We have to show this one. In which interval? I. So whenever we talked about prove that or show that is one of the easiest concept. We will only find f dash x and we will check that whether it is greater than or equal to 0. So the greater than 0, actually we have to show, so we have to obtain anyhow. So since we have f of x is equal to x plus 1 by x, we have this one. I will get f dash x. X differentiation, the differentiation of x is 1 and 1 by x have a minus 1 by x square. So we found f dash x. Now only to speak that it is your I, and what do you think about here, that whatever the value of x you will put, it will always greater than 0. Why? It is 1 upon x square. Students, whatever the value you will put, even of a negative or a positive, between these two you will always get a positive answer. How it is so? Look at, we have to show that function is strictly increasing, meaning we have to show that f dash x is greater than 0. So I ask you, does this greater than 0 for this interval? Okay, you can check. Look at minus infinity to minus 1, there are lots of values. Can you take any value between these two? Can you take any value between these two? Okay, I am taking minus 2. Put here minus 2. Minus 2 square, positive 4. 1 upon 4, less than 1. Definitely 1 minus 1 by 4 will be positive. So okay, from 1 to infinity, can you take any value? Like 2 or 3. 1 by 3, so 9. 1 minus 1 by 9 is a positive. So I would speak that since for all x belongs to I meaning this one, 1 minus 1 by x square is always positive. It is never 0. Look, it is a 1 minus. So 1 is always there. So it is never 0. So always positive, and so that f dash x is a positive. When f dash x is a positive, function is strictly increasing in the set I, and what I was defined, it was disjoint from minus 1 to 1, and the meaning of disjoint is except minus 1 to 1. It was a closed interval, so that I took open interval here. So this was a simple question, so you just have to check and have to write only, and this is enough. Okay, now I want to take more question of the exercise. Question is 18th one. Prove that function is increasing on R. Very simple. What to show? What is the meaning of R for all the real number? What to show? Increasing. What is the meaning of increasing? We have to show f dash x greater than or equal to 0. So first, okay, I'll find f dash x. Look at f of x is equal to x cube minus 3x square plus 3x minus 100. I'll find f dash x. 3x square 6x plus 3. I do differentiation. Then I have a simple trick. I'll take out common 3. X square, 2x and 1. And very good thing which I can see that x square minus 2x plus 1 is exactly x minus 1 whole square. Now I ask you that, what do you think about the nature of f dash x for all the real number? Look at it is square. It is always positive. Meaning whatever you will put the value of x, it will give us always positive. And by putting x equal to 1, 1 minus 1, 0. Meaning you can get 0 or you will get positive answer. For all, look at how to write. For all x belongs to R, 3x minus 1 square is either positive or equal to 0. It means that f dash x positive or equal to 0, and that means that f of x is increasing in the set of real number, and that is the answer. So hope you are getting, because the questions are very easy. After doing the tough questions, I think it should be very easy for you. And we finish this very first exercise, actually 6.2. 6.1 is not in your syllabus. So we'll over the concept here, and we start the new topic. The topic is tangent and normal. So very few things I want to start initially. Look at this is very interesting concept actually, students. This is very interesting concept, and probably question will come from this section. So we have two things, tangent and normal. So how to derivative or differentiation is interconnect with the tangent, how it correlate with the tangent and normals. Look at this is very interesting. The thing is, first I want to tell you something special, that you know about the meaning of tangent and of normal. Suppose it is any curve, it is any function, and it is a curve y is equal to f of x is any curve of the function. You know the meaning of tangent. Tangent is a line touches to the curve at a single point. This is a P called point of contact, and this is a tangent. This is a tangent. You should know. Now we have, this is called the normal. Actually, on the point of contact, the line which is perpendicular to the tangent is called normal. It's very important that it is passes from the point of contact. You know, this is also a perpendicular line on the tangent, but it is not called a normal. Normal in this particular that area will call to normal the line which is perpendicular to the tangent and passes from the point of contact. Okay, so in this particular region, in the picture, what you can see, that we have a few things which is to know. In this picture, we can say that we have a function, definitely will be given. We have a tangent. Sometimes we have to find the equation of tangent. Sometimes we have to find the point of contact. Sometimes we have to find the equation of normal. Sometimes we have to find the slope of tangent. Sometimes we have to find out the slope of normal. Those sentences recently I told, these are the requirements may come in questions. So we have one by one study about all. So okay. So first of all, I tell you about the gradient of the slope of any line. You know, in class 11th, you remember that we saw that this is the line. This is the line where this line is making angle theta with a positive direction of x-axis in anti-clockwise direction. This theta gives the slope of the line, and slope of the line is m will be tan theta. That was certain, because already we studied in class 11th. And this is also called slope intercept on the y-axis, but we don't want to concern about all. We just have to focus on the slope or gradient of the line, that depends on the angle made by the line with positive direction of x-axis with tan, that angle gives the slope of the line. That is very simple. Okay, till now what you have got? If you want slope, you need theta. In this picture, what I am telling you now, suppose you are given, look at very interesting, I am telling you. This is axis, this is circle suppose. And suppose the circle is x square plus y square equal to 25. This is circle. So interesting thing is that suppose it's a point 3 and 4. Suppose this point is 3 and 4 and the circle passes from this point. And suppose I draw a tangent from the point P and I want its slope. I want its slope. I want its slope. So what is the difference between these two questions? This time you concern about the line. We don't want to make a figure because figure is a secondary. I just want to tell you about this is the tangent which is itself a line. This is the tangent which is itself a line, and I am trying to find the slope of this tangent, meaning slope of this line. Okay, what we studied here, that if you want the slope of any line, you want theta, meaning that theta you must know, but this time theta is not given. So the new thing which I am telling you, that this is a curve, this is a point of contact and tangent, this is some angle making with the x-axis, but this angle is disappear, this is not given, and I want its slope. So let me tell you one thing, that what you get the derivative of the function dy by dx, it is none else but it is a slope. When we concern about the graph or graph of meaning curvature portion of any function, this is a graph of the function. What is the function is given with any point P, which is a point of contact you can call. When you draw the tangent by taking P as a point of contact, we won't find the slope of that tangent. This is also a line, but we don't have here the angle. We can also find the slope of the tangent just by finding dy by dx, because in this concern dy by dx is none else, it will be your slope of the line. Look at, I tell you how to do it. Differentiate with respect to x. This is just a implicit function. The differentiation of x square is 2x. This is 2y dy by dx, and this is 0. So can you find out dy by dx from here? Minus 2x upon 2y. Let's cancel it now. X upon y. This is not slope right now, but when you will put the point of contact value x equal to 3 and y equal to 4 here, you will get proper slope. Meaning I would write that slope of the tangent at point 34, this will change in m. And just putting x is equal to 3 and y equal to 4, whatever the value will be getting this called m. And it's a very good proof that it is making what angle? It is making obtuse angle. And you know that when you concern about the theta, something like with this method also you can get that when you have a theta, this time what is this looking? Obtuse angle. And when theta is obtuse angle, definitely m is negative. So okay, that time I tried to tell you that whenever we have to find the slope of any tangent, what is requirement? You just have to go on dy by dx and put a point of contact. In that you will get the slope of that tangent. Slope of the tangent. Look at this time I just have right now or recently told you how to find the slope of the tangent when the point of contact is given. So what to do? Only take a curve, it will be given, do differentiation, get your dy by dx and put your point of contact. That will be your m. So in this particular, slowly we'll reach on some difficult areas, but very initially it is very enough to go through this concept. I just want to tell you only one small example so that you will be a bit confident. Example number 14. Find the slope of the tangent of the curve y equal to x cube minus x at x equal to 2. Look at, this is a question. It's very simple. Let me make a rough picture. Question says slope of the tangent of the curve. So okay, I am making curve like that. This time I drew the whole circle, but okay, that time we were confident, but this time y equal to x cube minus x it's an uncertain picture. That time we cannot predict that what kind of picture it is. So only I just make a curve here like that, and this is what? This is nothing, x cube minus x, and this is a point of contact P, and suppose it is a tangent. It is a tangent. I don't want to make the axis, x-axis or y-axis, something like that. Okay, what to do? At x equal to 2, it's very interesting, meaning that 2 is given. I don't know what is y. I don't know what is y, no matter at all. This is sufficient. This is sufficient. X is given only, y is not given. So whole meaning is like that. Okay, what to do? Y equal to x cube minus x is given. dy by dx is equal to 3x square minus 1. You have got dy by dx, and this will be your m by putting values of x and y. But y is not here, no matter, x is only 2. So I'll write at x equal to 2, m will be. At x equal to 2, m will be. So this is gonna be m. So m will be 3 into, look at the value of x is 2. So 2 2s are 4, 3 is 12 minus 1, 11. What you have got? M equal to 11, meaning slope of this tangent at this point is 11. So this is the question from my side. So this is enough because it is continuously spoken here, 25 minutes around. From after example 14, we would have some more examples and definitely some question of the exercise. You can try from your side initial 4 questions, and that is your job. I won't tell because all based on same. So please do that. Thank you.